Okay, in this video we're going to talk about combinations. So it is a rule for counting experimental outcomes used when selecting n objects from a set of big N objects. With combination, order does not matter. So AB equals BA, right? Order doesn't matter. Why do I bring this up? Because we're going to talk about permutations later, and with permutation, order does matter. Here's the equation for it. But let's walk through an example, and then we'll show how the example matches up with the formula. So let's say I randomly put students in pairs. So 2 students in a pair, obviously, from a class with 6 students. How many combinations of 2 can be selected? So here is our sample space, right? We have the 6 students, A, B, C, D, E, and F. What are the possible combinations of 2? Let's go through them. We could do A and B, A and C, A and D, A and E, A and F. We get to the end of the list, so we'll start with B. B could be paired with C, BD, BE, BF. End of the list, so we'll start with C, CD, CE, CF, DE, DF, and EF. So if we count those together, 1, 2, 3, 4, and so on, we get 15 different combinations. So we can do this by hand. That wasn't too bad. But imagine if I said I have 100 students. How many possible combinations of 2 are there, or 3, or 4, or 5? That's going to take you a lot of time, so it's best to use the equation because you can solve it a lot faster. Also, again, notice order does not matter. So AB equals BA. It wasn't as though I got to B and I went, oh, wait, we got to do B and A, right? Because remember, order doesn't matter. So AB equals BA. You do not see a separate count for BA. Otherwise, we'd have a different number here. So make sure you remember that order does not matter with combinations. So let's look at this example with an equation. Right, so here's our equation. I read it like this one because it's easier, and two, that's the way I learned, but it's the exact same thing, right? So what we're doing is we have big N and little n. So you can kind of think about it as you pick little n from big N. So right, so this is our big N, it comes first, right? So those are all the possible students that we have, but we're interested in only picking 2 from the 6, right? So you pick little n from big N. So if we write this out, here's the equation. So big N comes on top, right? So big N in this case is 6. So 6, this is read 6 factorial. What this means is you just multiply 6 times 5 times 4 times 3 times 2 times 1. Right? So whenever you see a number, you just multiply it by all of the numbers that come before it, all the way to 1. So 2 factorial is 2 times 1. 6 minus 2 is 4. So 4 factorial is 4 times 3 times 2 times 1. So you can multiply all of that out and get 15. I'd like to point out that a lot of this stuff cancels out, so please don't sit there with your calculator multiplying 6 times 4 or 6 times 5 times 4 times 3 times 2 times 1 divided by blah, 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 blah. Right, if you notice, 4 times 3 times 2 times 1 is written right here as well. These actually cancel out. So really we just have 6 times 5, which is 30, divided by 2 times 1, which is just 2. So 30 divided by 2 is 15. So just look for little shortcuts like that. Another big shortcut is just do it in Excel. So Excel has a combination function. So it's just combin. And then you have big N, little n. So if you plug that into Excel, you will get 15. So that's really the gist of combinations. So in the next video, we will talk about permutations.